welcome to ternary ionic naming. A ternary compound has 3 or more elements in it. So it has to have at least 3, sometimes it has a couple more. What makes these compounds ionic is there is one positive ion and one negative ion in the compound. In a ternary ionic compound, there's a positive ion and a negative one. One of the ions is something we call a polyatomic ion. So take a moment and look at reference table E on the inside of your reference table. Poly means many, and atomic means atoms. So these are many atom ions. I guess I shouldn't have that S there then. Sorry. What a polyatomic ion actually is it's a group of atoms that are bonded together that carry an ionic charge. These always operate as a group, and you should never separate them. They can be separated by chemical means, however, for your purposes in naming and formula writing, do not separate them. What basically happens is, as a group, somebody has gained or lost an electron. We don't really care exactly where that happens. We just need to know overall what that charge actually is. To find polyatomics, use the easy button, table E. So there's a lot of great information on here. We have the names of the polyatomic ions. We have the formulas of the polyatomic ions. And we have the charges for the polyatomic ions. So you're gonna notice you have names. The formula is right here, and then that's followed by the charge. Anytime you have just a plus or just a minus, like in the case of nitrate, this is actually -1. And I know that they write these like, this one's written 2 minus. That means the exact same thing as -2. I'm not sure why they write them the opposite way that they are written on your periodic table. Doesn't make a whole lot of sense, but they mean the same thing. So here are a few examples of some polyatomic ions, just to give you kind of an understanding what you can think about these looking like. So for the nitrate ion, this is an N with 3 O's. Now, this has a -1 charge overall. Somewhere an electron was gained. We don't really care where that is. In the sulfate ion, we have an S with 4 O's. And somewhere 2 electrons were gained. We don't really care where that is. But that gaining and losing of electrons is what allows ionic bonding to occur, so we have ionic compounds here. The ammonium ion is a little bit different because it's one of the positive ones. Most of these are negative. This actually loses an electron as a group. Phosphate ion is somewhere in there gaining 3 electrons. So if we have to put two species together and form a ternary compound, we're going to start by looking at the periodic table and looking at table E. So I've got sodium, which is Na. I'm going to look up its charge, +1. And I've got the sulfate ion, which is SO4, -2. I know it's written on there as 2 minus. I just write it as -2. It's just what I do. It doesn't make any difference. Now you're going to go ahead, do +1, and your -2, and we're going to crisscross just like we did yesterday. So you take this 1 and this 2, bring down the 1, bring down the 2. Now when we bring down that 1, that just means we're using one group of the SO4, so we don't actually need to write that 1, but we are going to write the 2 with sodium. So this is going to be Na2. SO4. I do have to look at our subscripts here. Keep in mind, this is one thing right here. This is another thing right here. So our actual ratio of subscripts is actually 2 to 1. That can be a little bit confusing. We have the 2 from this guy. We have 1 of this group. We kind of ignore that 4 and the 1 that goes with sulfur here. Most of the time, it's pretty straightforward and easy, but you want the lowest number ratio of the individual groups that make up this compound. Sodium's +1, we have 2 of them. Sulfate, we have 1 of them, and its charge is -2, giving us an overall charge of 0. So our charges did add up to 0. So our final compound, Na2SO4. We have to put together calcium nitrate, Ca+2, nitrate. Be really careful. Nitrate is different from nitrite. When we take our charges, we're going to bring down this 2. We're going to bring down this 1. is going to give us Ca1. Chemists, we're lazy, we don't write that. Now, we need to tell people that we're using two groups of NO3. So this 2 right here means that we have two groups of these guys, okay? So we don't want to actually like add the 2 and 3 or multiply the 2 and 3 or do anything weird like that. We don't even want to distribute it. What we're actually going to do instead is say, hey, I got this group of NO3. I'm using 2 of them. Now we have to look and make sure that our subscripts are in the lowest whole number ratio. We got 1 calcium. We got 2 nitrates. 1 to 2 is the lowest whole number ratio. Calcium's charge is +2. We got 2 nitrates, each at -1, which is making that balance out to 0. And this is a graphic way of representing this over here. So this is our calcium right here. We use 1 of those. Each of our nitrate groups is shown separately here. A lot of people ask, why can't we write this, for example? What this would actually look like is a Ca and 2 ends bonded together with O's maybe sticking off like that. That's not okay. That's not the same thing. Those ends aren't really bonded together. That's not really how this compound is laid out. So we absolutely cannot do that. So what we have to do instead is use that parentheses to show that we have 2 groups of nitrate. So here's a few examples to try. Go ahead, pause the video, and I'll put the answers up in just a moment. To run through these and give you a little explanation, we have Mg plus 3, carbonate is CO3, I wrote the wrong charge of magnesium. That's not going to work. Mg is plus 2, carbonate is -2, so those charges actually cancel out just like what we did yesterday. When you have the 2 here and the 2 here, those are going to go away. Put this at a 1-to-1 ratio. Barium phosphate, barium's charge is +2. Phosphate's charge is -3. Putting that 2 there, putting that 3 there. So you're going to notice we wrote Ba3 and we put our PO4 in parentheses. That's really important. I don't know why my rubidium looks like that on my answer, but rubidium's charge is +1. Sulfate's charge is -2. So you're bringing down that 2 and putting it right there, and then the 1 comes down here. We don't need a parentheses with this one. Some people have asked me before, like, what happens if you write that? That's not a big deal. It's not the professional, best, most correct way to write that, but at the level that you're at, that's absolutely no problem. And if it makes you feel better to put those parentheses there, that's okay. If you write the 1 outside, I can live with that at this point. So magnesium and hydroxide, this one can be a little bit tricky because people say, okay, when I bring down this 2, I want to just attach it to that H right there. I don't need parentheses because there's no other number there to get screwed up. However, this is a problem. In this compound, which is the correct version of this compound, we're using 2 groups of OH. We have 2 O's, 2 H's, 1 Mg. Okay? So we have a total there of 5 atoms. If we write this differently, so for example, if we were to write instead MgOH2, we only now have 1 oxygen right there because we've only put that H with that 2. We also can't distribute this. We do have to say, hey, we have 2 of those groups. So you need to make sure that you use parentheses. Hydroxide is a very easy example to forget parentheses on, so be a little extra diligent there. Ammonium and chloride, I just like to point out ammonium because it does have a positive ion in it. You do everything exactly the same. Bring it down the 1, bring it down the 1. These actually cancel, so you just get NH4Cl. NH4 could need to be in parentheses. If you had brought down a 2, you would put that in parentheses. These are actually extremely easy to name. So when you're naming these, if you see 3 capital letters, that's a clue to you that you are going to be using reference table E. So I'm looking at this guy. I know I'm going to use reference table E. What's helpful is usually to identify which part of this comes from reference table E. Just take a minute, find something on this that looks like reference table E. Cyanide ion. So you can write the name of each species in the order it's written. So we have potassium, have cyanide. Step 2, you are done. Do not change the ending. Leave it as it is. There's an exception to this. You do change the endings of things from the periodic table. Do not change endings from table E, but you do change endings from the periodic table. So in the case of ammonium, this would be bromine, okay, because this is NH4Br. We don't want to leave this as ammonium bromine. Instead, we want to change our ending, and this is going to become ammonium bromide. So if something comes from the periodic table, you ide its ending. If it comes from reference table E, you do not ide its ending. Go ahead and try these examples. Pause and I'll put the answers up in just a moment. So you've got magnesium nitrite. That is not nitrate. Be very cautious with this. And the reason for this is that there is a 2 right here instead of a 3. So it is a nitrite ion. NH4F is ammonium fluoride. We did change the ending because we had something from the periodic table. Rb2SO4 is rubidium sulfate. So these are pretty easy to write formulas for from here. What you really have to be careful about is always looking at your endings. It can be very confusing. The sound of nitrate might make you think of nitrogen. There is nitrate in the there is nitrogen in the nitrate ion, but it's not the same thing as regular nitrogen from the periodic table. So the difference between ending in ide and ate or ite is actually really important. So we're going to write each of these ions in their charges. Magnesium +2, nitrate, and you have to match that up exactly. Make sure you get an O3, -1. We're going to go ahead and crisscross, use parentheses when necessary, and we're going to get MgNO3, 2. Our ratio is 1 magnesium to 2 nitrates, so that's the lowest whole number ratio. Magnesium's charge is +2. Each of those nitrates charge is -1. They do add up to 0. So MgNO3, 2. Here are a few of those to try. I'll pull the answers up in just a minute. Go over the crisscross, pause your video. So in strontium thiosulfate, that's quite a compound there. We've got Sr +2. Thiosulfite ion is S2O3 -2. So you're actually pulling down a 2, pulling down a 2. Those 2's are canceling to just Sr, S2O3. Sodium phosphate is Na+1, PO4 -3. Pulling down our 1, going down our 3. No need for parentheses here because we're only using one of the phosphate group. Barium chlorite, read that nice and carefully. So barium's charge is +2. The chlorite ion is ClO2 -1. We're going to pull this 2 down here. Since we're pulling something other than a 1 down, we are going to use a parentheses. Magnesium, Mg+2 permanganate. So you're going to go and find permanganate on there. That's one we don't use a whole lot. MnO4 -1. Pulling down this 2. Pulling down this 1. And last but not least, I wanted to give you one where you saw a parentheses with ammonium. So since oxygen's charge is -2, we have to pull that down there. We are using two groups of ammonium, so we do put that in parentheses and use the 2 there.